All right, 7-6, we're going to introduce function operations. So, two things to learn today, two objectives. First, we're going to add, subtract, multiply, and divide functions, and then we're going to get into the composite of two functions, what to do when we put two functions together. So, that'll be our new vocab for today, composite function. We'll talk about that once we get to the second objective, but first things first, let's get our skills checked. So, real quick, I'll do 1 and 5. You'll be responsible for the rest. Number 1, the domain. If we remember, the domain is are the x values. 0, 2, and 4 would be the domain for number 1. And the range are the y values. So -5, -3, and -1. And we do want to put these in order. So if they're out of order, rewrite it so it's in order and no repeats. Hint on number 2. Okay. All right. So, and on 3 and 4, all the x and y values that you could pick. Okay. So see if you can get that for 3 and 4. Number 5, let each function, evaluate each function for the given values. So for 5, x is 2. So we're going to plug that in. We're going to say f of 2 is 3 times 2 plus 4. Excuse me, 3 times 2 is 6, plus 4 is 10. So if you plug in 2, if your x is 2, then your y is 10. 2 comma 10 would be the point if we were graphing it. All right, so do number 6, 2, 3, 4, and 6, and when you're ready to go, let's get going with 7, 6. Okay, so objective 1, operations with functions. So a function is what we've seen back here, some sort of expression dealing with variables. And so let's look at an example. If an airplane has an airspeed of 415 miles per hour, then f of x equals 415x represents the distance traveled, right? Depending on how many hours you travel. If the wind speed is 30 miles per hour, then g of x equals 30x represents the wind. And so if you put them together, a composite here, f of x plus g of x, sorry, not a composite, but just adding the functions together, you'll have 415 plus 30, or 445x, okay? Represents the distance traveled by the airplane flying with the wind. So if you're flying and the wind is pushing you, the wind's behind you, we would go faster than just flying on our own. So functions work just like normal algebra. If we're going to add two functions, we're going to add them separately. If we multiply, we would just multiply, so probably foiling. Subtraction works the same way, and division works the same way. Remember, you cannot have zeros in your denominator, so we're going to get into that for the domains. All right, so the domain is what can exist for f and g. All right, and when you do the quotient, you can't have any x value in the denominator. So we'll look at that as we go forward. So example 1, we're going to add and subtract. So when we add and subtract, we're going to say 3x. So we'll just say this first, f of x plus g of x, and that's how we say them, f of x, g of x. F of x is 3x plus 8. If it helps you, you can put that in parentheses. Plus 2x minus 12. And let's combine our like terms. 3x and 2x is 5x. 8 plus -12 is minus 4. So that would be f of x plus g of x. And then we'll do f of x minus g of x. And so we'll have 3x plus 8 minus, and the parentheses is helpful because that negative is going to distribute here. So 3x minus 2x is just 1x. But then what happens if you minus a negative? You're going to add. So 8 plus 12, you're going to get plus 20. All right, for both of these, we do need to find the domain. For both of these, is there any number that you can't use for x? We could use any number we wanted, right? We could use positives, we could use negatives, we could plug in 0 for x. So we're going to say all real numbers is our domain. And a shortcut for writing that sentence is you can write R with 2 lines like that. Kind of like the paragraph symbol, but with the R. So that's all real numbers. All right, your turn on understanding check 1. See if you can do f plus g, f minus g, and make sure to find the domains. All right, multiplying and dividing. So f times g, we'll do that first. So we're going to FOIL here. X squared minus 1 times x plus 1, just substituting in the functions of f and g. And first, x cubed, outside, x squared, inside, negative x, and last, minus 1. Is there any number we could not plug in for x? Nope, we could use everything. So the domain is all real. Now let's divide. F over g is going to be x squared minus 1 over x plus 1. And we can factor this into x plus 1 and x minus 1 all over x plus 1. This is going to cancel, and so our answer is x minus 1. But remember that we can't have 0 in the denominator. So we know that x plus 1 cannot equal 0. So x cannot equal negative 1. So that's going to be our domain. We'll say our answer, x minus 1, and then we're going to say x can't equal negative 1. So we could pick any number for x we want, except for negative 1. So usually when we have problems with the domain, it's going to come from dividing, but not always. And we'll see more of that as we move on with Algebra 2, and a lot of this happens in pre-calculus when we get there. So in any case, try understanding check number 2. All right, now let's talk about compositions of functions. So this diagram is a nice thing and just kind of showing the order. So if we have f of x and then we have g of x, okay? If we put x in to some function where we're being squared, okay, it comes out as x squared. And then if we put it into another function, x plus 4, we would take x squared and plug it in for the x value, and it would come out as x squared plus 4. So we're just doing them in order. Okay, so composition of functions. Let's read it here. The output from the first function becomes the input for the second. So what we got as the output of the first function, f of x, turns into the input when we go to do the second function, g of x. Okay? And that's a composite function. When you combine two functions, you form a composite function. So a combination of two functions. All right, so the way we write it is g of f of x, and you can write it like this, g then parentheses then f then parentheses x, or g circle dot here of f of x. Okay? We're always going to work on the inner one first, and f would be the inner one as well. Whatever we get as our answer to the inner one, we'll use to plug into the outer one. So let's see how this works. So we have f of x and g of x, and we want to do g of f of negative 5. So I'm going to write it like this with the parentheses so we can kind of see it in steps. So first we're going to do the f of negative 5. So I'm just going to have g with the parentheses hanging on outside. So f of x is x minus 2, and wherever we see x, we're going to plug in negative 5. So we're going to have negative 5 minus 2, and so we're going to have negative 7. So if we plug negative 5 into f, we get negative 7. Now we take negative 7 and plug it in here for g of x. So it's negative 7 squared, right? We take the negative 7, plug it in for x, and the output is positive 49. Okay? All right, so see if you can work that through for understanding check number 3. All right, last one, real world connection. Suppose you are shopping in a store, the store in the photo, okay? And so there was a picture of a store over here. Didn't copy that one, but you have a coupon worth 5% or $5 off any item. Use functions to model discounting an item by 20% and to model applying the coupon. Okay, so we've got two different things going on. So we've got, we'll use f again. Now you could use h of x or p of x. It doesn't matter, but f and g get used a lot. So there's one, f of x is, the first one means whatever our price is, x, we're going to lose $5. So x minus 5. That's if we use the coupon. G of x says, okay, we got a different option. We're going to have things on sale by 20%, right? So that's going to be x minus 20% of x, which if you combine that is 0.8, 80% of x. If we get 20% off, we have to pay 80%. All right, so that's part A. We've got our two functions. Let's do a composite to figure out how much we would pay if the clerk applies the discount first and then the coupon. All right, so the discount is g of x, so that's going to go first, and then the coupon. Okay, so it's f, and g of x is 0.8x. Okay, and then so it's going to be plug 0.8x in for x up in the f function, and we'll get 0.8x minus 5. Okay, so we'll take 20% off and then subtract 5. Use a composition to go the other direction. We're going to do the coupon first. So this was part B. This is A. Part C. Okay, now we're going to do g of f of x. So f of x is x minus 5. And so g of x minus 5 is 0.8. Plug in a new x, x minus 5. If we distribute that, we get 0.8x. And 0.8 times 5 is minus 4. Okay, so let's compare these. 0.8x minus 5 or 0.8x minus 4. Okay, you're going to take $5 off down here, but only $4 off over here. So you're getting a much better deal if you do the 20% off first and then subtract the $5. All right, because the other way it's going to always be $1 different. All right, so follow through with that information on understanding check number 4. Try to get all the way through that, and any questions, we'll go over it in class. Good luck.